So the question is find the total force. I'm not quite sure. We'll have to take a guess at what they mean by total force. In newtons, if a car has, and K, I'm guessing, is the coefficient of friction of 0.001 with the road and accelerates at 4 meters per second squared. So we have a car on a road, assuming it's horizontal, and it's accelerating. Let's assume our motion is to the right. So if we draw the forces acting on this, of course, that's acting downward. It's on a surface. Surfaces always exert forces perpendicular. So the force it exerts is upwards, and we call that the normal force. The car's engine would have to supply a forward force, and let's label that, we'll call that the engine force. Again, I'm guessing that this is friction. So there's got to be some friction that opposes motion, and that would be labeled F. So if we look in the horizontal direction, we can see that there's the engine supplying a force, and we'll say that's in a positive x direction. In the negative x direction is this friction force. And when I put those two together, they're not balanced because the mass accelerates. So again, I'm supposing the total force they're talking about is the force supplied by the engine. So we would have to calculate the force from the friction, the mass, and the acceleration. Now, we do have the mass and the acceleration, so we can determine this, but we don't have the friction force. So there has to be some way to calculate it. So let's hold off on that right now. We do have an equation for friction that says that it is equal to the coefficient of friction times the normal force. Normal force, we do have this coefficient of friction. How do we find the normal force? Well, the normal force acts in the vertical direction, and it is a positive vertical force, whereas gravity is in the negative direction. Now, those are the only two forces that we're aware of. And when we combine those two, there's no acceleration up nor into the road. So we can say that the mass does not accelerate. There is zero acceleration. So in this equation, if I move this Fg to the other side, we can see that Fn, the normal force, is equal to Fg, and we calculate that by taking the mass times the value of gravity. You might use 9.8 meters per second squared. So we have that the normal force equals mg. Well, that helps out because we can plug that into this equation. And so now I have friction equals mu times the normal force, which is mg. Make some room for us here. So now plugging that in, we have the engine force minus friction, which is mu mg equals ma, or this, I guess, the total force, the mass of the car times its acceleration plus the coefficient, that k value, times the mass of the car times the value of gravity, whatever it is you use. And that should give you your answer for the total force.